Hello everyone, welcome. Can you hear me? Okay, thank you. Just we're waiting 1 minute, then we start. Okay, so we will start today's session. So I hope already all of you get the previous recorded video class and also get all of materials, okay, for practice 4 hours slide. Okay. So after completing the 3 hours live training program, then we talk about the problem solving for previous class. Okay. Okay, let me share my screen. Okay, can you see my screen? Is it visible?
Yes, it is visible.
Okay, thank you. So let's get start. So basically we discuss about that how to filtering and displaying the satellite images, different types of satellite images, mainly Landsat, Sentinel or MODIS, how to create the satellite composite or band combination, how to export the satellite images, okay, how to import, filter, reduce, clip, and display the raster data in Google Earth Engine, and time series analysis of the different types of indices, and how to export the different types of shapefile or how to create the annual image composite. So I think here all of you already know about the basic remote sensing. Okay, I think here all of you already know about the basic remote sensing and how remote sensing works. So this type of knowledge, I think here all of you already have. Okay. So anyone any problem about the basic remote sensing, you can also inform me. Any problem for the basic remote sensing or just I ignore this part? Mainly for basic remote sensing, mainly how it will work and different types of remote sensing. This type of things is okay for all of you or any problem for anyone? Okay, I think there is no problem for the basic remote sensing, how it will work and what the satellite or wavelength or energy sources, okay, or in atmosphere, surface reflectance. So I hope already all or electromagnetic spectrum. So I hope already all of you this type of knowledge, types of remote sensing, okay. Then based on platform, okay, satellite and or sensor. So I hope already all of you already know this type of knowledge. Then resolution, types of resolution, okay, image, different types of image properties, radiometric correction, atmospheric correction, okay, or different types of theoretical part for the basic remote sensing. I hope already know about this type of topic. So just I start from this, just skip this part for the basic remote sensing. Okay. Okay, so today's session I discuss about that how we can easily filtering satellite images. So different types of satellite images. So here already use the different types of sources we already use for the suppose ArcMap or GIS software. We just simply download the satellite images from the different sources. Suppose one source is it's called the USGS. Earth Explorer. So I think here all of already use this site to download the satellite data. We already use this site for downloading the different types of satellite data, as well as we also use the another source for the Sentinel Hub. Okay, Copernicus. We also download the satellite data, but now we are using the Google Earth Engine or cloud computing platform. Okay, so for that we don't need to download any kinds of satellite imagery. We can easily access all of satellite imagery from the Google Earth Engine data catalog. And if you check the data catalog from here, just you can see the browse data catalog, then we can find out all of data set for different types of remotely sensed data. You can see the climate and weather data, suppose surface temperature data, then different types of climate data, okay, precipitation data, lot of data, atmosphere, different types of atmospheric data or weather data, different types of imagery, mainly Landsat, Sentinel, MODIS, or some specific place. It also provides the high resolution imagery. Suppose for the NAIF, it's one kind of high resolution imagery. It's only available for the US. We can also use this type of imagery also from here. Different types of geophysical data, different types of terrain data, land cover data, agriculture data. Not only for that, if you check suppose Landsat, then we can get all of Landsat collection. Okay, basically it's provide the NASA and Google. You can see this type of data: Landsat 9, Landsat 8, Landsat 7, Landsat 5, Landsat 4, Landsat 1 to 5. So all up for the different time period, we can easily find out the different Landsat collection. As well as if you click on the Sentinel, then we can easily find out all of Sentinel image collection for the Sentinel-1 SAR data. This is the Sentinel-2 multispectral instrument data. Then ocean color, Sentinel-3, then also different types of gases data, suppose tropospheric instrument. So we can easily get all of data. Click on the MODIS, then we can find out the lot of MODIS product, daily product of MODIS. You can see the daily product or monthly product. So different types of MODIS, it provides the different types of information we can easily get from here. So now this type of data, how I can filter and how I can use for my own specific time period, how we can use for my specific study area. We already know about that in the Google Earth Engine, one data type, it's called the image collection. Okay, image collection is one kind of data type. So this image collection mainly set of images, more than one image called as the image collection in Google Earth Engine. Suppose I have only two images. These two images we consider as a image collection because it's more than one. So always more than one image consider as a image collection. And only for the one image, suppose I find out only for the one image, it's just image. So image collection and image, this is the two data type in Earth Engine. So image collection basically more than one. Suppose I have two images, so there it's called the image collection. More than one images, it's called the image collection, and only one image, it's called the image. So now when you work with image collection, we need to use some function. Okay, we need to use some function because it's a one kind of data type, and image, this is the another data type. So for the image collection, we need to use some specific function, and for the image data type, we need to use some specific function. And this type of function we can easily find out under the docs tab. Not need to memorize anything. You can simply open, you can see the image collection and image. So just when I click, I find out all of function. So this type of function I can only use for the image collection. Suppose I have a image collection, so I can easily apply different types of function only for this section. You can see when I click, I find out all of function related to image collection data. So all of function I can only use for the image collection. Suppose I have an image, then I can use only for this type of function. Only use this type of function because this is the section of image. So image and image collection, they are the two types of data. We already know about that. Image collection mainly more than one, and image only for the one. Okay, so one image. So how I can filter the image collection? You can see MODIS, then Landsat, then Sentinel. Not only for that, all of satellite images is a image collection. Suppose I simply search here charts. So it's one kind of image collection. Oh, sorry. You can see this is charts. It's one kind of image collection. So from here you find out the precipitation information, daily and painted, two types of, you can see e.image collection. And how I can get, you can see e.image collection, it means that it's a image collection. An image collection means that more than one image. So it's one kind of image collection. Also you check the others, suppose Landsat, Sentinel, Modis, all of are the image collection. So image collection is one kind of data type. So now how I can filter, just click on the Landsat 9, suppose top of atmosphere I choose. So you can see it's image collection. Okay, so image collection is one kind of data type, and when you filter image collection, I need to use only for this function, which function available in my section. If you check the image collection section, this is the image collection section, I need to use only for this function. Okay, so let's a practical example. Suppose I choose for Landsat 9, top of atmosphere. So it's one kind of image collection. It's a Landsat 9. This image is available between this time period, and it's provided USGS and Google. And when you're using this type of data source, suppose from the Google Earth Engine data catalog, this type of image is already, all of correction is done. Suppose atmospheric correction or enhancement already done for Google Earth Engine, because it's a pre-processed data. Okay, pre-processed data. But when you are download the data from the main source, suppose this is the USGS website, when you download this data from here, we need to lot of correction for atmospheric correction or enhancement. But when using the Google Earth Engine data catalog, not need any kinds of correction, because it's a pre-processed data. Okay, so let's go try to show the practical example. Suppose I want to use this data, it's one kind of image collection. So this data set I need to import in my code editor. So we can import the code editor two way. Normally, if you just copy this snippet ID, just copy this snippet ID. This is the every image collection, we find out the snippet ID, or every data set we find out this type of snippet ID. Basically, snippet ID, it's one kind of directory. Okay, it's one kind of directory. In this case, it's a Landsat 9, collection 2, tier 1, top of atmosphere. So it's a directory. Okay, so this directory, when I go, then I find out the all of Landsat 9 image collection between this time period for the whole world. So let's go try to check. Just copy this snippet ID and paste on your code editor. Just I paste. So it's one kind of image collection. So I just simply import, and after take a variable, mainly just create a folder. Suppose I create a folder, this folder is stored all of images. So how we can create the folder, we already know about that. Just take the var keyword and put any name. You can put any name you can put. Suppose I put the name is L9. Okay, suppose I put the folder name is L9, and this folder I just stored all of image collection. Okay, between this time period 2021 to 2025, between this time period, all of images I simply store it, and for the whole world. So let's go. Now I want to check how many images are available. Okay, how many images are available in my collection, I need to check it. So for that, we need to use a function. If you check this function, mainly called the size function. Size function basically help you to count how many images. Size is one kind of function. It's count total image in a collection. Okay, so if you check the size function, where is it? Yes, size function, you can size. Click on here. So return the number of elements in the collection. Suppose in this collection, how many images are available, we find out when I apply the size function. So now this image collection is stored in this variable. I want to check how many images are available in this collection. Just print, just simply use the print function and then call the L9, because this variable is stored this all of images. Okay, and then apply the dot size function. So when I apply the size function, it count total image in my collection. So let's go, what happened, just run the code. So now you can see it show the number computing. So any collection, suppose it can be feature collection or it can be image collection, I want to check how many elements are available in my collection. All time we use the size function. Okay, size function, it's computing how many image or how many element, it can be feature or image collection. Okay, So we find out this is the large number of image collection, okay, for the whole world between this time period 2021 to 2025. Okay, so this is my image collection. I find out this image collection I need to filter. Okay, so now how I can filter? For filtering process is different some factor. Suppose for filtering factors. Suppose first factor, it's called the region of interest. So now this number of image collection, it's available for the whole world, but I don't need for the whole world. I need only for the specific area of interest. So first factor is the region of interest, mainly where you need the image. Okay, so we can say that first factor is mainly your location or your study area or where you need the image. So where you need the image. So this is the first factor for filtering. So I have a large number of image collection for the whole world, but I don't need for the whole world. I need for the specific region of interest. Suppose I need for the Dhaka city boundary. So then I just only work for the Dhaka city boundary, not for the whole world. Okay. So this is the first factor for filtering. Second factor, it's called image metadata or image properties. So image have a lot of properties. Suppose cloud cover is one kind of image properties. Then tier 1, tier 2, this is another kinds of image properties, or cloud pixel percentage or cloud cover land. You can easily get all of properties from here. You can see the image properties. Click on here, you can get a lot of property. You can see basically for we are use the cloud cover or cloud cover land. So cloud cover, it's mainly you just simply set a value. Suppose I need the image less than 1% cloud cover, or I need the image less than 5% cloud cover. Okay, so it's one kind of image properties filtering. Suppose I choose cloud cover will be not more than 1% cloud cover. Okay, suppose I need the less than 1% cloud cover for my study area. So it's filtering mainly your image metadata or cloud cover land. So it's mainly how, suppose I need the less than 1% cloud cover, but some place less than 1% image is not available, then what we can do? So I will explain one by one, then get the idea. So this is the second factor, it's called the image metadata or image properties. Third factor, it's called mainly time. So time, basically when you need the image. Suppose I need the image in year of 2021, summer season, rainy season, or month of January, or any time period. So when you filtering any image collection, so in this case I have this image collection. So this image collection I filter based on region of interest, image metadata, and time. So let's take the practical example. So first of all, suppose region of interest. So where you need the image. So for that you can simply import your shapefile from the asset tab. So previous class I already discussed about that, how we can easily import the shapefile or how we can easily filter or different source, suppose USGS dataset or FAO dataset. So this type of data, it's provide the different boundary or shapefile. If you want, you can also draw the study area also. So here I already imported one shapefile. Suppose let me just open. I already import my shapefile. Suppose I want to work for Dhaka city boundary. Just I click on here, it will be imported. So this Dhaka city boundary, I already imported in my asset tab. And it show the table, default variable name, it show the table, but we already know about that variable name can be anything. We can put any name as a variable. We can put the name, suppose ROI. Okay, so first factor, I need the satellite image for my ROI, for my Dhaka city boundary. Dhaka city boundary is stored in this variable ROI. So for filtering the ROI, which function I need to use? So you can simply check it from the docs tab and check the function, another function. It's called the filter bounds function. So you can see it's a filter bounds function. Basically, it's filter a collection by intersection with geometry. Geometry, it can be point, line, or polygon. So in this case, I simply imported my study area as a polygon of Dhaka city boundary. Okay. So when I apply the filter bounds function, it's filtered a collection by intersection with geometry for my study area. And you can see what is the argument. Argument is the geometry, mainly point, line, or polygon. So let's go try to apply this function for filter bounds in this collection. So for that, just I take the another variable. Okay, let me write in here. Suppose take the another variable. I put the variable name, suppose filter region. You can put any name as a variable. And now this image collection is stored in a variable. This variable name is L9. Just call it L9 and apply the filter bounds function. Okay, filter bounds with my study area. In this case, Dhaka city boundary. It is stored in this variable RY. Just I call RY and paste here. Okay, so now this variable filter region, it stored only for those images which images are available in your Dhaka city boundary or intersection with the Dhaka city boundary. So let's go. We try to check it. Just print and call the filter region. Then check how many images intersect with my boundary in Dhaka city. Just use the size function again and run the code. So now we find out that 152 images. Okay, so 152 images intersect with my region of interest. We find out. So we filtering our study area. Then suppose from 152 images, I need only for those images which image will be not more than 1% cloud cover. Okay, less than 1% cloud cover, I need only for this type of image. So it's called the filter metadata. If you check the function filter metadata, so it's one kind of function, filter metadata. So for filtering the image properties, we are use it. And you can see the three argument: name, operator, and value. Name mainly image properties name, operator mainly less than, or you can see the less than or equal, also get the equal, less than, greater than, value mainly 1 2 3, which value we need. So now from 152 images, I need only for those images which image will be not more than 1% cloud cover. So let's go. Just I use the filter metadata function. Take a variable. I put the variable name, suppose filter cloud. Okay, we can put any name as a variable. So now from 152 images, this image collection is stored in this variable filter region. So now from the filter region, I just choose only for those images which image will be not more than 1% cloud cover. So just apply the filter metadata. Okay, filter metadata. And three argument. First argument, it's the name of image properties. We can easily find out the name. You can see the image properties. I choose suppose cloud cover. And it's a string, so must use the quotation because it's a string. Then operator, I choose less than and set the value 1. So now from 152 images, I just choose only for those images which image will be not more than 1% cloud cover. So now let's check how many images are available in my study area which will be not more than 1% cloud cover. So just print again and call the filter cloud and use the size function to compute how many images are available less than 1% cloud cover. So we find out the 29 images. So this 29 images in my study area less than 1% cloud cover. But what is the duration? This duration between this time period 2021 to 2025. But I don't need for the whole time period. I need for a specific time period. Suppose year of 2025 or any month, any specific season or any specific duration, I need these images. So for that we use another function. It's called the filter date function. So if you check the function from here, filter date, you can see filter date. So shortcut to filter a collection by a date range. We simply set the date range. Suppose now I have total 29 images, but I don't need all of images. I need only for those images which images are available in year of 2025 January to suppose October. I need only for this type of image. So for that, simply apply the filter date function. So let's go. So for that, take the variable. Suppose filter date. You can put any name. And now from 29 images, this 29 images is stored in this variable filter cloud. Just I call the variable name and paste here and apply the filter date function. And now define the start and end time period. So I put here suppose year of 2000, suppose 24 January, 1st January from year of 2024, suppose December 31. I take the 1 year. So now let's check how many images are available in this 1 year. Just print and call the filter date and apply the size function to count how many images are available and run the code. So we find out only for the 4 images are available in my study area. So first of all, it shows a very large number of image collection. We find out. So this large number of image collection, just filter. First filter for study area, where you need the image. Then second filter, less than 1% cloud cover, how many images. And finally, when you need the image. Okay, suppose I need the image January, December. So we find out the total 4 images. So this 4 images is intersect with the Dhaka city boundary. This 4 images less than 1% cloud cover, and this 4 images is available between this time period. Okay, so this is the process for filtering. Suppose I have a large number of image collection for the whole world, but I don't need for the whole world. I need only for the Dhaka city boundary or any specific boundary. So just use the filter bounds function. So for the where, we just use the filter bounds function. Okay, just you remember it's a filter bounds where you need the image, and define the geometry. Geometry basically your shapefile variable name or any point, line, polygon, simply define. And then filter metadata. How? Suppose in this case I check less than 1% cloud cover. So some place less than 1% is not available. So first you check less than 1% is not available, then it shows the 0 value. 0 value means that less than 1% image is not available. Then you need to increase the cloud level. Suppose less than 5% or 2%, 3%, 30%. Then check, okay, which image is available or which cloud cover is available. You try to check it. But in this case, we find out the less than 1%. But when you work with the river bank or any or coastal area or any place where there almost cloud formation, so then you don't find the less than 1% is not available. Then we need to increase the cloud level, and when increase the cloud level, then we find out the some cloudy pixel on our satellite images. Okay, this type of cloud image we can easily remove. So inshallah I will show you that how we can easily remove the cloud in the next class. Then you can easily get the more better idea. So in this case, less than 1% is available for my study area, and we find out the total 4 images for my study area. So for the filtering image data, just use here the filter metadata function, and filter metadata function have a 3 argument. First argument is the basically it's called the image property. Okay, basically name, image property name. So I choose the cloud cover, it's my image property's name. Then second property, it's called the your operator, and third property value. Okay, so simply put the cloud cover, so we can easily get the image properties name from the satellite images information. You can easily find out from the data catalog page. Okay, then less than and put the 1. So now we find out the 29 images, and after that when you need the image, for that simply use here the filter date function. Okay, filter date function, and define start and int. So I find out the start date, so January 2024 and December 31 2024. So you find out total 4 images is available for my study area. So now I want to check all of information. Cloud level, image acquisition time. Okay, so all of those information for the total 4 images I want to check it. So for that simply print this variable filter date, because it is stored total 4 images, just run. So then we find out the all of information about the total 4 images. So first of all, you can see it show the image collection. Type is image collection. Data type is the image collection. Image collection more than 1 image. Okay, and we find out the all of images have this type of band. Okay, and total 4 images we find out. So now we can check. You can see this is the first image, second image, third image, fourth image. So click on the first image. Then we can check all of property for the first image. Click on the properties. So you can see find out for the first image all of information for the first image. Suppose cloud cover land, tier 1, collection number 2, data acquisition time. We find out, you can see this is the time about the acquisition time. So it's the first image information. Then check suppose second image, same process. Just click on the properties. Then we find out all of information about the second image. Then third image. Then check all of information about the third image. Okay, and fourth image we can easily find out that all of fourth image. Okay, for this. So let's go and try to use. So how I can use this type of image? So we find out the total 4 images. Okay, for the image we can create the 2 types image. Suppose one image, it's called the single date image. Okay, or without composite. single date image. Suppose I want to use only for the single date image. Suppose this image I want to use. Suppose this, you can see this image I want to use. So it's a single date image only for the one tiles we find out for this image. And another, it's called the composite. So after some time I'll show you that how we can easily create the composite, because sometime we need to use the single date, okay, imagery. So let's go try to show you that how I can visualize this type of single image. Suppose this image, this image, this image I want to display on my map for the single date image. For that, just click on here. Suppose just like click on here, you can check the ID. Every image we find out the ID. Okay, this is the ID. We find out that every image have a ID, this type of ID. Every image have this type of ID. So just simply copy this ID. Okay, and you can say type is the image. So it's a image, single image. Okay, total 4 images. It's a single. This is the first image, second image, third image. Just copy the ID and then paste here. Okay, just like copy and then paste the ID. So now this ID I need to store, just use a function for image visualization. If you check for the function, I want to work now this, I want to work the image. So you can see it's an image. So just click on the image. You can see the image ARGS, well, directory, or you can see Earth Engine asset ID. So this is my ID. I already pasted the ID, and then use this function ee.image to operate the represent an Earth Engine image. So just I copy this function and paste here and use the parenthesis. This is the ID. Okay, so now this is the single image. I just use this function and now take a variable to store it the image. Like I want to create a folder. Suppose I put the folder name is image and equal. So now this image, store it in this variable, single image. Okay, if you print, just print the image and run the code, it show the image computing. Okay, it's not the image collection, it's just a single image. Type is the image. Okay, so this image I want to visualize on my map. So for that, just use your map.addLayer and call the image and run the code. So now it's add a layer but not focus on my given study area, but I want to focus. So for the focusing, we already know about the function map.center object. I put here suppose RY, this is my shapefile variable name, and put the suppose zoom level 10 and run the code. So now it directly focused on my given study area and we find out this type of image. Okay, so this is the tiles of my image, and this acquisition time, if you check, this is the time 1st March 2024. So this is the image, but this image I want to use only for my study area, only for my study area, not other place I don't need. So that just use the clip function. If you check in the image section, you find out a function. It's called the clip. Where is the clip? Yeah, clip. You can see the clip function. So clip, this function basically only work for the image data type. Suppose I have a image, so then I can simply use the clip function. But suppose I have an image collection, so then you just apply the clip function, that it not work. So let's go and try to use the clip. And what is the argument for the clip? Geometry, mainly your shapefile variable name. Just call the clip. I just apply in here clip and define my study area. This is RY. So now if I run the code, it's just clipping my study area of Dhaka city boundary. And we find out the image only for the Dhaka city boundary. But it show this type of visualization. It's a default visualization. Now we try to set the image or band combination or stress the visualization, then it look more perfect. So how I can add the band combination? For that, you can see the layer 1. It show the layer 1. Click on here. And you can see the different types of band combination you can set in here. Mainly 3 bands making 1 combination. Suppose I choose red, then green and blue, RGB. It's called the natural color band combination. And stressing level, basically it's one kind of visualization process. When I stress 98%, then it show this type of reflectance value. And we can use the different types of stressing for the different data. So it's one kind of visualization process. Suppose when I put the 98%, then it use this type of mean and max range and show the visualization. if I use suppose 90%, then you and use the another maximum and minimum range and show the visualization. So maximum time I just use the 98% because it show look more better. Okay, then just apply. So now it display the result for RGB or natural color we find out, and it's a single date image. Okay, not composite. So these are the satellite images we find out for this time for the single date. And now we can easily use this image and make the different types of remote sensing work. Suppose vegetation analysis, land use, land cover, different types of work, or LST monitoring, different types of work we can do. So this visualization, it just show we need to import. You can see the import button in here. So when I click on the import, a new line of code added in my code editor. Okay. So just copy, and then set after the object name. So in the map.add layer, previous class we discussed about this function. There the total 5 argument. So first argument is the EE object. Basically, it can be image or image collection or feature collection. Second argument is visualization parameter. So we simply set the visualization parameter. So now this visualization parameter add this type of visualization which I set in here. So then I simply import the visualization parameter and copy the variable and set after the object name. Okay, then if you want, you can simply put here the layer name. I put the layer, it show the default layer 1. Suppose I put the layer name RGB. Okay, we can put any name as a layer name. So now if I run the code, this visualization is set it in my map. Okay, you can see it's set it in my map. Suppose now I want to use the another band combination. So it's called the RGB. Then I want to put suppose false color band combination. So for that, what can I do? Just same process. Just click on here again. And I want to add the band combination. Suppose near infrared band, then red band and blue. Stressing I keep the 98% for this band combination. Apply. So now it's create the another band combination. We find out. And we are using the different types of band combination and also use the different types of band ratio to identify different types of feature from the surface. So when I talk about the land use, land cover, and how we can take the training sample, then you can get the more better idea about the this type of band combination. Okay, so now I just use this type of band combination. Now we can easily find out the vegetation show as a red color. Okay, water body show as a black color or dark color. So I want to import the visualization. So same process, just click on the import, a new line of code will be added. Okay, for the second visualization. So I want to represent as a layer. So I want to create the another layer and use this visualization parameter. So same process. Just I copy the same line of code because my image is same, but I want to use the different visualization. Okay, just I call the variable name, this variable name, image param2. And then paste here. Okay, and then I put here any color combination name. Suppose I put say false color. So now run the code. So now it's created the 2 layers. We'll find out in here. Okay, suppose I want to add the another band combination. Okay, in the remote sensing we use the different types of band combinations. Suppose I want to add the another one. So in this case I choose so short wave infrared one, then near infrared and blue. Stressing so 98% I keep, and then I apply. So now you find out this type of band combination. So it's very useful to identify agricultural land or vegetation when you're using the, and also barren land or wetland we can also identify. So let's go try to import the visualization. Same process, just import, and I want to add the another layer for this visualization. So same image, but I want to use the different visualization. Just copy the same line of code and paste. Image is the same, but visualization parameter is different, and we put any other's name. Suppose I put the vegetation, you can put any name. So now run the code. So now it's create the 3 layer for the different same image for but different visualization. So now we can easily use this type of visualization, identify this is the water body, this is the vegetation, this is the barren land or build up. Okay, as well as we also use different types of bend ratio to identify different types of mineral. So this is the image and it's only for the single date image. But single date image sometimes it's not work for the big study area. Okay, suppose I need the satellite image. Suppose I want to identify forest area for the whole country boundary of Bangladesh, or I want to identify suppose land use land cover map for the whole country boundary of Bangladesh, or land surface temperature for the whole country boundary of Bangladesh. Then single tiles is not enough. Okay, for when you work with the big study area. But for a small study area, suppose this type of Dhaka city boundary or any other small study area, so which fully cover my tiles, so then we can easily use the single date image. But when you work with the big study area, suppose I want to identify forest area in Bangladesh, suppose I want to identify bamboo in Bangladesh, all of where the bamboo is available, so then we need the whole country boundary satellite images I need for the whole country boundary of Bangladesh. So then single date image is not enough, because for the Bangladesh whole country boundary of Bangladesh single tiles is not enough. So then we just apply the composite. Okay, so let's go how we can easily create the composite then and apply for the big study area. When you work with the for the big study area, different types of analysis, suppose land use land cover or identify forest or identify bamboo, different types of work we do for. So let's go I try to show how we can easily work. So I hope you can get the idea how to work with the single date imagery. So we can say after final filtering, we find out the 4 images. So from here we can just simply choose the different images. So for the first image, second image, third image, fourth image, same process. Okay, so you can check some image is not fully fill up your boundary, suppose some gap, so then you try to check the another image, then to check the another image. So which image is the fully cover my study area, this image I choose and then I work with that. But sometime for the big study area is not possible for the single date imagery, so then we are just applying the image composite. So let's go how we can create the image composite. Now we try to discuss about that, then you can get the better idea. And this is the process for the single date imagery. So for any image collection, so in this case I show the example for Landsat 9, same apply you can also do for the Landsat 8, 7, 5, you also try. So I also keep some assignment, you also try, then you can get the idea. So let's go now how we can create the image composite. So image composite, okay, just I just write in here. Image composite. So image composite basically it's one kind of process of combining multiple satellite images into a single representative image to reduce noise like clouds and improve the quality or analyze the sense over time. So basically image composite, when you apply, then it also help you to increase the image quality also, because in this time when I apply the image composite, I just combine multiple satellite images from the same or different dates, okay, into a single represent image to reduce the noise or also cloud or also haze and improve the image quality also, or analyze the change over time. So this is the another benefit to use the image composite. Image composite help you to improve your image quality. But when you are using the single image, then it not get this type of things. We find out the some unnecessary pixel value for the cloud or others. So now I want to create the image composite. Suppose I need the image for the whole country boundary of Bangladesh. So for that you can simply import the Bangladesh boundary shapefile. If you want, you can simply import from the asset tab, or if you want, you can simply use the data shapefile from this web data source USDOS. So this is the international country boundary polygon. So just I simply import the data source and then I just take only for suppose Bangladesh boundary. I put the variable name suppose AOY and then call the table. This table I want to filter. So how I can filter Earth engine filter dot equal. What's equal what? Put here country name. Country name is Bangladesh. Bangladesh. Okay, so now I want to work with the Bangladesh boundary. I put the variable name is the AOI. Okay, so I want to use the same code. Okay, so for that I simply comment this type of line. Now it's not need, just I comment. Okay, and in here I simply choose the Bangladesh boundary. It is stored the AOI. Okay, just I filter bounds with AOI. Other keep just same. Okay, so now let's check how many images I find out for the whole country boundary of Bangladesh. This time period, we find out the total of 57 images. Okay, 57 images is covering the full boundary of Bangladesh, and this 57 is the less than 1% cloud cover, and this 57 image is available between this time period. Okay, so now I want to use the total 57 images and make a composite. Okay, so how I can make the composite? So we are using here the different types of composite. Suppose one composite, it's called the median composite. Another composite, it's called the mosaic composite. Okay, so median, mosaic we use here, and also use here suppose mean composite, as well as we also use sometime also use here the max composite or minimum composite or mean composite. Okay, so now for the for as well as also average, it's called the mean composite. So for the mean composite, basically smooth surface we find out. Okay, so it's mean composite, basically it compute the your average pixel value. Suppose average pixel value, it's compute, and then we find out the smooth surface. Suppose basically it's helpful when you work with the NDVI. Suppose you want to identify suppose average NDVI or average LST. So this type of work we are just use the mean composite. And then median composite, basically it's compute the middle pixel value. Okay, suppose middle pixel value, and it's help you to remove clouds and has from your images. Okay, so you find out when you use the median composite, suppose your place is very cloudy, so when you apply the median, so it just take all of images. Suppose I have total 57 images. When I apply the median, so then it take the all of from the all of images, it just take the middle pixel value all of images and create the one composite image, and it automatically remove all of unnecessary pixel for cloudy pixel or haze and give you the more clean image. We find out when you apply the median composite. Then we also use here the mosaic. Okay, so mosaic basically it's help you to it join the image side by side. Okay, join image side by side. It not calculate any kinds of statistical suppose mean, average, or others. So just is join all of image by stack. Okay, and create the one composite. Just join all of those. So basically it's help you to merge tiles over a study area, over a region. Okay, then minimum, so same, it just compute the average value. So I already write it, say average, and then max, same process, so it identify highest reflectance. Okay, highest reflectance, highest reflectance value, or it's called the brightest pixel. So it mainly help you to identify vegetation or NDVI peak. We can identify using that vegetation or NDVI peak, and mean basically minimum. It take the lowest reflectance or darkest pixel reflectance, and it's help you to identify water or shadow analysis. We can also use the minimum composite unit when you work with for water or shadow analysis. Basically this type of median, mosaic, max, mean or average, this type of composite we are used in the Google Earth engine for the different purpose. We are using the different composite. So in this case, suppose I want to work for the median. So I have total 57 images. So this 57 images, I want to apply the median. So if you check from here, docs function. So median function we find out under the image collection, because 57 is the image collection. And I want to apply the median, this 57 images. So you can easily find out the function median in this section. If you check, where is the median? Yeah, median, is the median, mean, max, okay, or mode, mosaic, okay. So I want to use suppose median, click on here. So you can see this median, it reduces an image collection by calculating the median of all values at each pixel across the stack of all missing bands, and bands are matched by their name, okay. Name, basically you can see this is the band name, b1, b2, b3, okay, just matching by their name. So I want to use it. So in my collection, so I have a collection total 57 images for the whole country boundary of Bangladesh. I want to apply the median. So now it returned me, you can see when I apply the median, so it returned the image. So I have a image collection. So when I apply the median, it returned me a single composite image. So let's try to apply it and check what happened. Okay. So take a variable. Suppose I put the variable name is the median image. You can put any name. Suppose median image. And I want to create the median image from 57 images. It is stored in this variable filter date. Just I copy and paste here. And if you check in the median, there is no argument. Okay, argument, there is, it's a null argument, not need put any kinds of argument. So just I apply the median. So put here dot median, and now I want to display the result. So let's map dot add layer and call the median image. So now it create the one composite. It's fully cover my study area of whole country boundary of Bangladesh. You can check. So you can see find out this type of imagery, but I other side I don't need. So further simply apply the clip function. Okay, now it's a image. So when I apply the median, this variable return a image, and I can easily apply the clip function, because clip function is only work for the image. So clip with my study area, which is AOI, which is stored at the Bangladesh boundary. So put here the AOI. So now run the code. So now you find out this type of image collection, and if you want, you can also add here band combination. Same process, just add the band combination. Suppose I put here that short wave infrared 1, near infrared, and blue. I just keep stressing 98% and apply. So now you find out this type of imagery. Okay, and further you can easily use this imagery to apply the different types of remote sensing work for the whole country boundary of Bangladesh. So land is land cover or vegetation analysis, different types of work we can do. And I want to import the visualization. Same process, just import, copy the visualization parameter and paste after the object name. And put the layer name, suppose VDMS. So now you find out this type of image for the whole country boundary of Bangladesh. Okay. Okay. Anyone, any question you can ask me, please. Okay, I hope you can get the idea how to create the single date image and also how to make the composite image. Okay. Okay, so in this case, for the first time, for your understanding, I simply put the different. You can see, I take a variable and also put the another take a function. Suppose for the filter bounds function, I take a variable, and also for filter metadata function, I take the another variable. Okay, for the filter date, I take the another variable. But it's unnecessary. If you want, you can simply take a one variable, and under this variable, you can put all of function. Okay, so let's go how we can write the code more better way. I will show you that. Suppose just I comment all of those, just simply select and press Ctrl and forward slash. So now it's commenting. So now I just take only for the one variable. Okay, suppose I take the variable name is image. Okay, so now all of function, filter bounds function, filter metadata function, filter date function, median function, clip function, so all of function I just keep only for the one variable. So call the L9 because it's my image collection. Okay, put the dot and put here filter bounds function with your study area AOI. Then put the filter, and spaces doesn't matter, we can put any space, there is no problem. Okay, there is no problem if you write here also, there is no problem. Okay, suppose I put here the filter filter metadata. Okay, that's less than suppose 1. Then put here suppose filter date 2024 1st January from 2024 December 31, and I would suppose median and clip with my study area with AY. Okay, so now I just use only for the one variable and put all of function together. Okay, so now this is my final result. I want to display suppose map.add layer and call the image. Okay, I just call the visualization parameter, then paste here and put the layer name suppose BD. Just run the code. We find out the same result. Okay, so this is the way we can write the code without taking the individual variable. Just take only for the one variable, and under this variable you just simply write all of function using the dot notation. So now this is my final image. Just I simply add the visualization, we can get the result. But for the first time I just show you explain one by one, so that's why I simply write this type of line. But when you write your code, then not need to follow this way. Okay? Just simply use all of function, take a one variable, and under this variable put all of function together. So now it's the image, it's a single composite image we find out for the whole country boundary of Bangladesh. Okay, anyone any question you can ask me. And after that we can also export this type of image. Suppose you can just export this image, and further you can also work with other geospatial software. It also possible. We simply export image, and this image we can easily export as a TIFF format. So further we can also use it for other geospatial software for the different types of work also. Okay, so I'll show you after some time how to export. And you also try for other image collection. You can see you also try Landsat 9. You can see the surface reflectance, same process. Okay, when you filtering the surface reflectance, you also try. Also you can see the Landsat 8, 7, Landsat 5, Landsat 4, Landsat 1 to 5, all of image collection for filtering, visualizing, creating composite, single date image visualization, all are the same process when you work with the Landsat. Okay, so we also try for different sources. Okay, and we also discuss about the another class how we can easily create the annual composite. Okay, so it's very important because annual composite, suppose I want to create a function, this function help you to get the imagery from suppose 1980 to 2025. Okay, then we can easily get all of annual image composite, and it also help you to identify land use, land cover, vegetation change, or also different types of work. It also help you. So this thing I also discuss about the further class inshallah, then you can get the more better idea how we can create the annual image composite. Okay, so you also try this type of other image collection for the Landsat. So now we talk about the Modis, because Modis have a lot of product. Okay, and all of product you can easily visualize same way. So you can see for the Modis, this is the Terra vegetation data set. land cover and watermarks data set, Terra ocean reflectance data set. Also you can see the MODIS land cover data set. So different types of MODIS leaf area index data set, solar radiation data set, photosynthetic activity radiation. So we use the different types of data for the different type purpose. We need to use this type of data. You can see the different Terra surface reflectance data. Okay, surface reflectance data. Also again the land surface temperature data. So it's one kind of ready-made product. Okay, for this type of data, for the MODIS we can easily use and make them analysis. Also you can see the land surface temperature 8-day temporal resolution. So this is the global data set, 1 kilometer. Okay, daily. So you can see the Terra Vision indices. So different types of product we can find out, and all products are the same process when you work. Okay, all product is the same process. You can see this is the evapotranspiration data set. Okay, this is the net evapotranspiration data set gap field. This is the gross primary productivity data set. So I just show you only for the one data set, and further you also try for any other data set, same process. Okay, so let me work for, suppose I want to work for this. Okay, suppose I want to work this data. So this is the one kind of data set. It's called the Terra Vegetation Indices, 16-day global, 250-meter resolution, 16-day temporal resolution. And if you check the data set, all of information. So this data set is available from 2000 to 2025. And this is the data set provider. And this is a snippet ID. Okay. Basically from this data set, we find out the two information, basically NDVI and EVI. Normalized difference resolution index and enhanced resolution index we find out in here. So I want to use this data set and I want to identify, suppose vegetation place for a specific time period from here. And what's the benefit to use the data? And we can already know about, you can see this is the Landsat data we find out, or also find out the MODIS. Okay, MODIS data. So what's the benefit to use the MODIS and Landsat? So first of all, Landsat data we find out it's a high resolution. Landsat is only for the 30 meter, but MODIS you can see it's 250 meters. Okay, so Landsat is good resolution than MODIS, but MODIS data set, it's a ready-made data set or pre-processed data set. So that's why you can see this data set already marks all of unnecessary pixel. Okay, so cloud shadow, heavy aerosol, water, cloud. So it already marks all of unnecessary cloud pixel. So when you're using this data set for any place, we find out the more better map for vegetation for the big study area. Okay, because it's a 250 meters resolution, so it's very work well for the big study area. But when you work with a small study area, suppose for the Dhaka city or more smaller area, you want to identify vegetation or land use, land cover, or any remote sensing work, then we try to use freely source. Basically we are use the Landsat or Sentinel-2. Okay, Landsat is 30 meter, Sentinel-2 is more better, it's a 10 meter or 12 meter resolution. So for the small study area, we can use this type of Landsat or Sentinel-2. But when you work with the big study area, then we try to use this type of MODIS data. Okay, and MODIS data, what is the benefit? Because this data set already remove all of unnecessary pixel. So when I use the data set, I find out the more better vegetation map for the big study area. So I'll show you that all of sensor, Landsat, Sentinel, MODIS, all of example, all of those I will try to explain one by one. Then you can get the idea how to use this type of satellite data for the different project. So first of all, I need to import this image collection. Just I copy and then open a new code editor. And paste here. So same process, just take a variable and store it this data. I put the variable name MODIS NDVI. You can put any name. So now this MODIS NDVI, it's an image collection. Okay, so in the image collection, if you check in this image collection, have a two bands, NDVI bands and EVI bands. So basically NDVI is the normalized difference vegetation index and EVI is the enhanced vegetation index. We already know about that, and both are the useful to identify for plant health or greenness or biomass. This type of satellite MODIS we are use. this type of NDVI or AVI, it also possible to compute using the Landsat or Sentinel-2. So inshallah further class we'll discuss about that, how we can easily work. So now it's a ready-made data. So you can see the NDVI and EVI we find out. But when you work with Landsat or Sentinel, we need to apply formula. So this is the formula. I simply search suppose NDVI formula. Just simply search. We find out this type of formula. You can see near minus rate divided by near plus rate. So this is the formula. So it's a high NDVI value indicating about the dense vegetation or good vegetation. Low NDVI value, it's indicating about that your sparse vegetation, okay, or low vegetation. And if the NDVI value is the less than 0 or negative, it's indicating about that water body or others or bare soil, this type of things. So this is the NDVI. Okay, healthy vegetation, it find out the more high value we find out for the healthy vegetation. Okay, and for the low vegetation, it shows the low value, and it's computed this type of rate near infrared and also red, because vegetation is the high absorb of the near infrared reflectance value. So you also read this type of thing, then you can get the more better idea or concept about the NDVI and how it will work and how to use the different types of for NDVI, suppose plant health monitoring or greenness monitoring or biomass monitoring, where you use this type of NDVI index. And now NDVI is a ready-made, because in this time we are using the Modis product, so it's provide the ready-made product of NDVI. But when you are using this, suppose this image when I use and make the NDVI, then I need to apply this type of formula. Suppose this type of formula I need to apply. So further let's discuss about that, how we can work this type of formula. So now we create the map. Okay, so now this from here I want to work for the NDVI. Just I copy the band name, and select. So from this image collection, I select only for one band of NDVI. Okay, and now select the time period. So filter date and put the time period. Suppose year of 2024, 1st January from year of 2024 December 31. I just choose. So now if you check how many images are available for that, just print and call the Modis NDVI and use the size function. For the 1 year, how many images we find out? 16 days temporal, we find out 23 images. 23 into 16, we find out the almost 1 year. It's covered the 1 year. So because our temporal is a 16 day, okay, for this data set. So for the 1 year, we find out the 23 images, 23 image collection. So this image collection, if you want without just I simply add the layer. So now it's load for the whole world, okay, because it's the whole world available. You can see. So we find the whole world NDVI map in year of 2024 without visualization. So now we try to add a visualization. Okay, so how I can add the visualization? Okay, this dataset already provides some you can see it's provide this type of demo color. Just I copy this color code and then paste in my code editor. So in this code editor, basically they are create a dictionary, okay, and put the keyword and key value, and also add the list of color hexacode. Okay, so this visualization variable name, just I copy and paste after the object name. And if you want, you can also put the layer name, suppose world NDVI 2024, and run the code. So now you find out this NDVI map for the whole country, whole world. Okay, we find out, okay, and we can easily identify where is the dense vegetation, where is the no vegetation. We can easily get this type of idea, okay, from this. You can see. Okay. So there's a whole world NDVI map, but I don't need for the whole world. I need suppose a specific boundary for country boundary of Bangladesh or any other country boundary or any place. So you can easily apply your asset tab. You can also import your shape file, or if you want, you can also use the dataset from here, USDOS website data source. Just import and filtering your study area. Suppose I just take a variable and filtering this dataset. Suppose ROI, and then call the table. This table I want to filter. So how I can filter? art engine filter dot equal. So what's equal what? Put here the country name and put the country, suppose I need for Bangladesh. So now Bangladesh boundary is stored in this variable ROI. Okay. So now this is, if you check, this is the map. Okay. This map, when I clip, suppose I just use the clip function of ROI. So it created a problem because we find out this type of problem. Okay. So we already know about that clip. This function only work for image data type. Okay. Only for image data type we can apply the clip. But now I have a image collection. Total 23 image collection. So now clip function is not work. Okay. So now I need to reduce this collection and make it one image, make a one composite image. Then I can easily apply the clip function, because clip is only work for the image data type. But I have a total 23 image collection. It's a image collection. So that's the reason clip is not work. So now how I can convert? It's a image from the image collection. Just simply apply the reducer. So reducer basically in the Google Earth engine, reducer, it's one kind of statistical operation. And using this operation, we can easily compute, suppose average, then maximum, then minimum, or standard deviation. We can also apply, suppose mode, different types of statistical operation you can do using the reducer. So now I want to apply the reducer. Suppose I want to compute the average NDVI. If you want, you can also check the maximum NDVI or minimum NDVI. Same process. Just simply use the max, mean, or this type of function. Suppose I want to apply the average NDVI in year of 2024. So for that, just apply the mean reducer. So just take a variable. Suppose I put the variable name is mean NDVI and call my image collection. So this is my image collection. I just call. So this image collection, I want to apply the mean. If you want, you can also apply the mean. Just use the mean function, but it's not the proper way. So now we are applying the reduce. So first of all, I define the reduce. Reduce mainly I just filtered the reduce. Reduce, then how I can reduce? EE dot reducer dot mean. Okay, so now it apply the reducer mean in from the 23 images. So now when I apply the reducer mean, then it work as a average single image. So now I can easily apply the clip. Just use the clip with my study area, which is ROI. So now let's check run the. Oh, sorry. So now this mean NDVI I want to visualize. Just I copy and add the layer and run the code. So now it display only for this boundary. I want to focus my boundary. Suppose map dot center object is ROI. Zoom level I keep suppose 10 and run the code. So now I directly focus my given study area. So you find out this type of NDVI map in year of 2024. We can also stressing and also find out the more better visualization to, and also download this type of map, and then we can also add the visualization from the symbology of ArcMap or QGIS software and add the different types of visualization. So I'll show you the further, inshallah, you can get the idea, no problem. Okay, suppose I need the map for another country, simply change the country name, then you can easily get the result. Suppose I simply put here Pakistan and run the code. So now you find out the Pakistan NDVI map in year of 2024. So any country, you can simply put the name, then you can get the idea. for the vegetation map for the in year of 2024. So we find out this type of map. Vegetation show as a green color. This type of green color, we find out the vegetation. Australia. Or you can also upload your own shapefile and also work with that. So now I just take all of country boundary from this data source. Okay, then I simply change the country name. Then it show the vegetation map for. Okay. Okay, we generate this type of vegetation map, but this vegetation map have a problem. So what is the problem? If you check the pixel value of vegetation, click on the inspector and click any place on the map, we find out this type of pixel or reflectance value for NDVI. You can see. So we need to rescaling this scale value, because if you simply search on Google, suppose I also check from here. So you can see NDVI always range from -1 to +1. Okay, so +1 or high positive value, it indicating about the dense or green vegetation. Okay, and low NDVI value indicating about that sparse vegetation, and negative values indicating about that water body. Okay, but now in my map, if you check, we find out this type of range. Okay, so that's a problem. So we need to correct range of NDVI. So now how I can make the correct pixel of NDVI? So for that, every data set, not only for this data, when you work, you check the scale value. If you check, it show the scale value. Okay, basically for the modis, we need to use this type of scale, as well also Landsat or Sentinel-2 or Landsat surface reflectance. We need to use the scale and offset value to get the proper pixel value. Okay, so every time when you work, you try to check the scale value is available or not. So if the scale value is available, you must use the scale value to get the proper pixel value for your data set. So for the NDVI, you find out this is the scale value 0.001. So this scale value I need to use in my image collection. I need to multiply with my image collection, and then it reproject the range -1 to +1. So every time when you work, you try to check in your data set scale value is available or not. If the scale value is available, you must use to get the proper wavelength value or proper pixel value. You must use, otherwise it shows some problem. So now how I can use this scale value in my image collection? I need to multiply. So if you want, you can simply use the multiply function. Suppose I just use the multiply function 0.0001. So this is my scale value, and if I run the code, I face a problem. So it shows a problem. So what is the problem? If you check, it show that multiply is not a function. If you check the problem, image collection, filter date, and multiply is not a function. So it means that this is my image collection, and in the image collection I apply the multiply function. Multiply function you don't find in this section. If you check the docs tab and check the image collection section, there is no multiply function, because multiply function, it's only work for image, not image collection. So if you check the image, we can easily find out the multiply function or add function or subtraction function. We can easily find out where is the multiply. Again, the divide function. Okay, equal function, first image. Where is the multiply? less than equal matrix max function mean mode multiply. Okay, so multiply function, it's only work for image data type, but now I want to apply it on the image collection. So that's why it show this type of message, multiply image collection, multiply is not a function. So now how I can multiply? Suppose this value I need to multiply in my collection. In my collection, I have total 23 image collection and I want to multiply with this value. Okay, all of images I need to multiply. I have a total 23 image collection. So now multiply is not work, but I want to multiply, need to multiply. So how I can do it? So for that, now we are just apply the concept of function. So previous class I discussed about the function. So function concept, I reuse function. Basically I reuse my code one by one and do all of images multiply. Suppose I create a function. Okay, this function help me reuse my code. Okay, and multiply one by one all of images. Okay, with this value, scale value 0.001. So we need to create a function. Okay, so this function one by one all of images multiply with the scale value. Okay, 0.001. So this concept, not only for that, lot of time we are using. Okay, for the different times we need to reproject the scale value for the LST or NDVI or any other data set. Just apply the same process. Okay, so now I create a function. This function help me to multiply all of images at the same time. Now we create a function, same process. Take a variable. Suppose I put the variable name is, suppose rescaled NDVI, and put the function keyword, and then put the element name, elements, and put the curly bracket. In this curly bracket we just put our argument. So now what is my element for this case? Multiply function is only work for image, single image. Okay, not multiple image. So for that I just take only for the single image. I just single element. Suppose only for the one element, single element, because multiply function is only work for single image, not multiple image. Multiple image mainly image collection. Okay, so I just take only for the one element. So this one element I just return this element multiply with this value 0.0001. Okay, so now it's a single image. So this single image I can easily multiply with this value. But now it's just only work for one image. But I have total 23 images between this time period. Okay, between this time period I have total 23 images. So I need to apply this multiply all of images. So for that, apply the another function. It's called the copy properties. This copy properties copy the image property after multiply, and it's apply all of images between this time period start and between this end. Okay, so just apply here system time start, it indicating about the start time to end time. So put here the system time end. So this function I again explain. So first of all, take a variable name of your function, equal sign, function keyword, take the only for the one element. So in this case we are just work only one element. Suppose img, you can put anything as a variable, any element you can take, and then put the curly bracket. So this element I want to return multiply with this value, but now I multiply only for the one element, but I have all of images I need to consider. So for that I just copy these properties after multiply of this element and apply system time start to system time end. It's indicating about this time period. So now this is a function and this is a collection. So this collection I need to connect with this function. Okay, you can see it's a separate code, so not need any kinds of link between the function and between the collection. There is no connection. Okay, so just I make a link or make the connection. So for the connection copy this variable, because this variable is stored at 23 image collection. Just copy and paste here. And for connecting, use here the map function, bracket start and close the bracket. So now this is my function and it's my collection. So from this collection, one by one image come in this function and multiply with this variable. Okay, so suppose first image just input and multiply, second image input multiply, third image input multiply, fourth image input multiply. Between this time period, basically this time period in my system, start time and end time, between this time period all of image is multiply one by one, one by one, one by one. So it's helped me to reuse my code again and again, and then multiply all of images and store it in this variable. So now if you check how many images, we find out the same number of images. Just take copy and now check, we find out the same number of images, but now all of image is multiplied with this value. We find out the 23 images. So now other just keep the same. Just I want to use this image collection, because this image collection rescaling the range. Just I copy and then I just calculate the average from using this image collection, and others keep the same. Just run the code. So now it shows this type of visualization, because you can check it show the mean 0, max 8000. So that's the reason we find out this type of result, but we can also change it. So for that you can simply stressing the data to keep the better visualization. So just stressing, suppose 98% I keep, it automatically show that you can see 0.15 this type of range. Just I copy and apply it for the mean, and 0.8 just I copy and apply it for this. Okay, and now if I run the code, so now it show the more better. And now if you check the value, click on the Explorer tab and click on this map, then we find out this type of value range. We find out this type of value range. So dense vegetation shows the high. So if you want, you can also change this type of color code. Suppose I just remove all of color code, it's not needed. So I put my own color, suppose blue color for the low, then suppose white, and suppose for green, and run the code. You can also add the more color. So now you can easily identify water body vegetation. Vegetation show the green color for the Columbia. So now you can also check the value. It show the range between -1 to +1. Okay, I find out this type of range. Okay, so now for any country, we are just use. Suppose I put here Japan. To get the more better visualization, just stressing for this new place. I keep 98% for my place. Apply. Then we can easily identify vegetation show as a green color. We find out this type of green color indicating about the vegetation. Other show the desert, this type of, there is no vegetation. So you can also download this type of data as a GeoTIFF file format. And further, you can also use the ArcMap or QGIS software to add the different types of color, okay, for the visualization and creating the map. Okay, so this is the process. Anyone any question, you can ask me, please. Any question or any confusion, you can ask me. Any question?
Mr. Raman,
Please.
yes, how do we download the map so that maybe we can just visualize it on
Yes.
when you want to present and something like that?
Okay, so I'll show you this process also, how we can easily download this type of map. So let's go. So in the Google Earth engine, we can export the map in the total 3 different way. We can export this map. But best popular method is that we can simply export this map in our Google Drive. Okay, suppose in the Google Drive we can simply use to exporting. Okay, so let's try to show you that how to export this type of map, then you can get a better idea. For exporting, you can simply search here export. So you can see export image to asset, export image to cloud storage, export image to drive. So this is the most popular. Cloud storage we need to buy. Asset, basically this is the asset tab. Suppose this map I just simply store it and store it in my asset tab, then we just use the asset tab. So further this map or this file I just use in my another project, so then we are just use the export image to asset tab. Okay, so it just help you to store it your file, GeoTIFF file, in the asset tab. Okay, in your asset tab. So further from this asset tab I can easily import in my code editor and use the another project. Or if you check the another, it's called the export image to drive. So it just export in your Google Drive. Okay, in your Drive we can easily get, and from the Google Drive we can simply download this file and use the other geospatial software. So all time for any exporting, we are just use the same code. Okay, for any image or any map, when you export, just use the same line of code, just paste here and then make a dictionary. Just I put here the dictionary, curly bracket start and curly bracket end. Then first of all you can check the image. This is the one kind of keyword. I put the key value. So which image you want to download or which image you want to export. In this case I want to export this map. Okay, this layer. Okay, this layer I want to export. So this layer is stored in a variable. Okay, basically this map is stored in a variable. Just find out the variable name. So which variable stored this map? So in this case, this variable mean NDVI, it stored this map. Okay, just I call it, just I copy and then paste here because it is stored my map. Oh sorry, it's not copy, just copy the variable and paste here. So all time for any map, suppose you just add the different layer, multiple layer. So from the multiple layer, which layer you want to export, just simply find out the variable name and then use in this first key value. Then description, it can be anything. We can put anything without a space. Any name we can put. Any name we can put. Suppose I put the NDVI. I can put any name without a space. Folder, you can put any name, so it's just create a folder in your Google Drive. So from the Google Drive we can easily download. So I put the folder name, suppose you can put any name as a folder, it automatically create in your Google Drive. So they put the folder name 34th. Yes. So now this folder is automatically created in my Google Drive and store it. So it's optional, it's not need. File name prefix need when you at the same time you export lot of layer, it's need. Dimension not need. Region is important. Region basically is your shapefile variable name. So this shapefile variable name, so this, if you check this ROI is stored this shapefile. Okay, just I call the ROI, it's my region of interest, define. Then scale is the resolution of your satellite imagery. Okay, for the modis, we are just use here this 250 meters. This is the resolution or scale. Okay. Then CRS, it's not need. Max pixel. Max pixel sometime we need when you work with the big study area. Okay, suppose you want to export the big study area, then you need to apply the max pixel. Otherwise, max pixel is not need. Okay. Basically, max pixel help you to increase the computation power. Okay, and 1e13, it's the highest max pixel value. Basically, default we find out the 1e8. So when you work with the big study area, first of all you try without max pixel. Okay, and if you face any problem, some problem we find out when you export in the task tab, it show the red alert sign. So you can simply check the problem. If you face the problem, then apply the max pixel 1e13, okay, for the big study area. Otherwise, max pixel is not need. Then otherwise it all is same, just not need for the export. So now run the code. So now task tab will be running if you check. Okay, you can see that just run and then just run. Okay, so now it's also depend on your file size and also depends on your internet connection. Then it will be exported in your whole drive. After that, you can simply download this GeoTIFF file, and then you can also work with ArcMap or QGIS software. So it's also working. Same process you also apply for this satellite imagery. So when you download the satellite imagery, Landsat or Sentinel, okay, then just apply the same process for any study area. Suppose, okay, let me show you for a small study area, otherwise take more time. Suppose I need the satellite image for Dhaka city. So RY is stored at the Dhaka city boundary. So just I put here RY and run the code. So we find out, okay, we also need to clip with our study area. Dhaka city RY. So run the code. And I put it say Dhaka.